Okay, so look at example 1. If P is equals to 2i plus 3j plus 5k and Q is equivalent to negative 5i minus 6j plus 7k, find P dot Q, and then B, determine the magnitude P and magnitude Q, and the last one, find the angle between P and Q. Okay, so as you can see, you can write this is vector P and this is vector Q. So we need to find the angle between these two vectors, but before that we solve it one by one. So P dot Q, right? So P dot Q is 2, 3, 5 dot with negative 5, negative 6 and 7. So the answer is 2 times negative 5 is negative 10 minus 18 plus 35, this is equivalent to 7. And after that, B, we need to find the magnitude for P. Okay, so magnitude for P, the formula is surd 2 square plus 3 square plus 5 square, which is equivalent to surd 38. And the next one, we need to find the magnitude for Q, vector Q. So it is negative 5 square plus negative 6 square plus 7 square, which is equivalent to surd 110. Okay, so the last one, we need to find the angle. So the angle, the formula is theta is equivalent to arc cos. So for this one, the vector is vector P and Q. So P dot Q divided by magnitude P, magnitude Q. So as you can see, all this value, okay, are given before. Okay, we have find this before. So we just substitute into the formula. So this is 7 divided by magnitude, which is surd 38, and this one is surd 110. So by using your calculator, you can find that your theta is equivalent to 83.78 degree. Okay, so this one example 1. Okay, look at example 2. So we want to simplify these two vectors. Alright, look at A. So A minus B, vector A minus vector B dot with vector A plus B. So we are going to simplify this equation. So as you can see, these two vectors, what we should do is we can expand all these vectors, okay, same like quadratic equation. So vector A dot with vector B, vector A dot with vector A, and then we can get plus vector A plus dot with vector B, and then minus vector B dot with vector A, and the last one minus B dot B. So as you can see, we can use the properties of dot product, which is A dot A is equivalent to magnitude A square. So A dot B is same with B dot A. So it's plus and minus, we can cancel off these two. And the last one, B dot B is equivalent to magnitude B square. So this is the simplest form. Alright, next B. If we have vector A plus with vector B, we need to dot with vector C. And then the next one, minus A plus C. We need to dot with vector B. So same like this before, we need to expand the vectors. So as we expand the vectors, the first one is A dot C plus B dot C, and then the next one is minus A dot B, and the last one minus C dot B. So as you can see, alright, A dot C, okay, nothing is the same like this, just same is B dot C is equivalent to C dot B. So this is 1 plus, this one is minus, so we can cancel off these two. Okay, so it's just A dot C minus A dot B. So this is the simplest form. Okay, now look at example 3. So if we have vector, given that vector A is 3i plus tj minus 2k, and vector B is 1 minus ti minus 3j plus 4k, find t. If vector A is perpendicular to vector B. So we use the rule number 3, which is if vector A and vector B is perpendicular to each other, so it means that A dot B is equivalent to 0. So we just substitute the vector A, 3, T, and then negative 2 dot with vector B. So B is 1 minus T, negative 3, and then 4, and then must equal with 0. So we expand these two vectors. Okay, so 3 times with 1 minus T, and then T times with negative 3, so you will get negative 3T, and then 2 times with 4, so you will get minus 8 equals to 0. So as we expand this equation, so this is 3 minus 3T minus 3T minus 8 equal to 0. And then we can find the value of T is negative 60 minus 5 is equal to 0. So negative 60 is equals to 5. And lastly, T is equals to negative 5 over 6. Okay, so this is your final answer for question number 3, example 3. Okay, so this is the last example. So as an exercise, you may do these two exercises, these two question, right? This question and another one is this one. Okay, so the suggested answer given. Okay, that's all for today. Thank you. Assalamualaikum.